So in this video, we are going to talk about how to write the chemical formula for a ternary ionic compound. And what that means is it's an ionic compound with a polyatomic ion. So remember, an ionic compound is one that has a metal and a nonmetal. A ternary ionic compound is one that has a metal and a polyatomic ion. Now, when it comes to writing the chemical formula with polyatomics, there are 12 polyatomic ions that you need to memorize, and these are the 12 that you need to know. And just one way to help you is if you notice, you need to know nitrate and nitrite. If you notice the difference, this is NO3 minus or NO3 minus 1, and nitrite is NO2 minus or NO2 minus 1. Ate to ite means you just take one oxygen away. So sulfate is SO4 2 minus, sulfite is SO3 2 minus. So that's a way to help you with some of those polyatomic ions. Notice that all of them are negative except for one. Ammonium is the only positive polyatomic ion, which means ammonium would come first in an ionic compound. So when it comes to writing the formula, it's going to be the same way that we've been looking at before. The first step is to write down both ions and their charges, and you always put the metal first, or you put the positive ion first. So write down both ions, write their charges, use your periodic table for any of the ions that come directly off. So if it's sodium, you'll put Na+, magnesium, Mg2+, things like that. Then you'll use the crisscross method like before. And then, if possible, reduce the subscripts. Now, when working with polyatomic ions, the polyatomic ion must remain the same, which means, for example, hydroxide is always OH. And what you will do to keep the polyatomic ions intact is you will use parentheses. So if you need more than one hydroxide, so let's say that you crisscross and you need more than one hydroxide, you will put this OH in parentheses and you'll put the number outside of the parentheses. So let's look at some examples. The first one is sodium sulfate. So first rule is to write the ions with the charges. So sodium is Na plus or Na1 plus or Na plus 1. Remember, those are always the same. Sulfate. So if you notice that it's sulfate, the ATE or ITE tells us that it's a polyatomic ion. Now, the only two polyatomics that end in IDE are cyanide and hydroxide. Every other one that ends in IDE comes directly off the periodic table. If you see ate or ite, that means it's one of the polyatomics that you need to know. And sulfate means you're going to have sulfur in it and some sort of oxygen. So sulfate is SO4 2 minus. So before, circle your value of your charge. So you circle the 1 and the 2 and you crisscross. Now remember, sulfate is always SO4, which means SO4 always needs to stay together. And if you want to always put the polyatomic in parentheses, that's fine. But then you crisscross and you write the formula. So the 1 comes down with the sulfate, the 2 comes down with the sodium, and it becomes Na2SO4. And what this means is you have 2 sodium ions, you have 1 sulfate, you have 1 SO4. So the next example is magnesium phosphate. So like before, we write our charges. So magnesium is Mg2+, and phosphate, again, 8 means it's a polyatomic, and the phos means you're looking at phosphorus. So phosphate is PO4 3 minus. Now remember, polyatomic ions always need to stay together. So phosphate always needs to be PO4. So I'm going to put that in parentheses. And then we will crisscross. So the 2 will come down with phosphate, the 3 will come down with magnesium, and we get Mg3 PO4 2. So notice the phosphate is in parentheses because PO4 2 is different than PO42. Notice we don't move this 2 and we don't distribute it, we leave it on the outside of the parentheses. And finally, the example is ammonium carbonate. Now, if you try to look on the periodic table, you're not going to find ammonium. That's because it's the positive polyatomic. So it's NH4 plus 1. And carbonate, again, carbon. And then the ATE means it's a polyatomic. So carbonate is CO3 2 minus. Now, just like before, any polyatomic. So polyatomic, poly means many, atomic for atom. So Polyatomic just means we have many atoms. So I'm going to put both of these in parentheses. I'm going to put both the ammonium and the carbonate in parentheses. Now we crisscross. So the 1 comes down with the carbonate. The 2 comes down with the ammonium. Notice that the positives and the negatives we don't worry about when we crisscross. All of the subscripts are always positive because that's how many atoms we need. And so the 2 comes down with the ammonium. So we keep NH4 in parentheses and put the 2 outside. And then we leave CO3. Now if you want to put CO3 in parentheses here, that's fine. The biggest thing is that NH4 is in parentheses with a 2 on the outside. So whenever you're dealing with polyatomic ions, you just always want to keep it in parentheses because you never want to change the polyatomic. Otherwise, if you change the subscript, you're changing the atom completely.